Hi everyone, in today's lesson we're going to begin a concept called integration. So far in this course we've only dealt with derivatives. So today begins the part in the course where we're actually going to talk about the opposite of the derivative, which is the integral. So we're going to begin with a lesson called Riemann sums. So first, a Riemann sum is a method for approximating the total area underneath a curve on a graph, otherwise known as an integral. So what we're going to do is I'm going to give you a picture of a graph, and I'm going to ask you to approximate its area under the curve using what we call rectangle approximations. So in this first video, we're going to talk about right rectangular approximations. Then tomorrow we'll worry about left, and then the day after we'll worry about midpoints. So let's just focus our attention on this picture for right now. So what I'll do is I'm going to give you a curve and I'm going to ask you to approximate the area under the curve given a specific interval. So here is the interval which we'll call A to B. So I would ask you what's the area under this curve over the interval from A to B using 4 rectangles. I have to tell you the amount of rectangles I want. So what you would do is you would start from the right, since we're talking about a right rectangular approximation, you would start from the right of the interval and you would go up to the curve. And at this point on the curve, you would go and you would draw down your rectangle. Then you would go up from that rectangle up to the right point of the curve and draw over your second rectangle. Then your third rectangle, you go up to the right point of the curve, go right over and then down. And then the last one up to the curve from the right side and then over. And what you would do is you would add up rectangle areas 1, 2, 3, and 4, and that would give us our approximation underneath this curve. And then they would ask you a question about whether this approximation would be an overestimate or an underestimate. Well, you can clearly see that we have extra area here, 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 and here that we didn't account for. So this is extra. Therefore, this particular example would be an over approximation. Now, what you're really doing is you're approximating the area, but eventually we're going to be able to find the actual area. And that actual area is found by using a method called integration. So this integration, this is the symbol for the integration. And we take the integration over a given interval from A to B, just as we have here, A to B, where A will be the lower point of the interval, so lowest value, where B will be the highest point of your interval. And we want to take the area under the curve, which we'll call f of x. This is some function which we'll call f of x. So this notation means to find the area under the curve over the interval from A to B. That's what this notation means. Find the area under the curve from A to B of some function f of x. And this is the actual area. We're going to be able to find that eventually, but for right now, we're just going to estimate its area using these rectangles. So let's move on to the next page and try an example. 0. So here we have a function. Let f be the function f of x equals 2 over x. They're saying if 3 subintervals of equal length are used. Now, anytime they say the word subinterval, they're talking about the number of rectangles. So you could write if 3 and then rectangles if you'd like. So if 3 subintervals or rectangles of equal lengths are used, what is the value of the right Riemann sum approximation for this exact area? So they're basically asking you to use this approximation over the interval from 1 to 7. And then round your answer to the nearest thousandth if necessary, and then state if your estimate is an over or under approximation of the actual area. So the way I want to do this, first things first, is let's draw a picture. I always think the picture will be the easiest way. So what I'd actually like you all to do is go to the y equals in your calculator and graph 2 over x, and then hit resume when you're ready. Okay, so after you put that into the y equals, you should have gotten some sort of curve that looks like this. So we're just drawing a sketch, doesn't have to be perfect, but the interval that I'm caring about here is the interval from 1 to 7. So I'm going to start by just labeling 1, 2, 3, 4, 5, 6, and 7. And I want 3 rectangles over this interval. So I've got 1, 2, 3, 4, 5, 6 spaces, but I want 3 rectangles. So it's obvious that every 2, I'm going to put a rectangle to space it out evenly. But sometimes it's not going to be that obvious. So there's a formula that we can use to find the width of each rectangle. And here it is, b minus a over n. A and b are the endpoints of the interval, and n is the number of subintervals or rectangles that you're looking for. So the first step that I'll do is find the width. Now we already know it's going to be 2, but let's just prove it with this formula. So the width will be the b minus a. So remember, when we have our interval, it's always a and then b on top. So b is 7, 1 is a. So we'll do 7 minus 1, all divided by 2, because 2 is n, where n is the number of rectangles that I want. Oh, excuse me, it says 3. So 3 subdivisions. So when we do 7 minus 1, we get 6. 6 divided by 3 is 2. So this will give us the width. Once we have the width, then we can go and draw our rectangles. So since I'm asking for a right Riemann sum, I start all the way to the right of the interval. So I'm going to start at the right, go up to the curve, and draw my rectangle with a width of 2 spaces. Then my next rectangle, I start at 5, go up to the curve, and go over 2 spaces. That was my width of the rectangle. And then the third one, go up to the curve, and then go over 2, and then there's my third rectangle. So in order to answer the question, we now just have to find these 3 areas and add them up. So step 2 is going to just be to calculate the area. So we know that the area of a rectangle is actually length times width. So the width we know is 2, we just need to find these lengths up here. So notice that these are points on the curve. So all you have to do to get this height is figure out what this point is. So if you already have your information in your y equals, all you actually have to do is go to the table of values. So we have x and y in our table, and I care about the height at 7, the height at 5, and the height at 3. So on your table, look for when x is 3, 5, and then 7. So why don't you go ahead and do that now and then hit resume when you're ready for the answers. Okay, so when x is 3, you should be getting 0.6 repeated. Now, 0.6 repeated is really just 2/3. And then when x is 5, we have 0.4. And then when x is 7, you have 0.2857. And this is 6 repeated. So the idea is to really, you only have to, it says estimate to the nearest thousandth, which is 3 decimal places. So we really should go 4 places and then round down to the third. So that's, you're going to notice how I went 1, 2, 3, 4 decimal places. The 0.4, we could just put 3 zeros after it, and then there we go. So what these y values mean is that, and when x is 3, this height here, when x is 3, is 0.6 repeated. When the height here is at 5, we're at, all the way over here is 0.4. And then when we're at 7, my height all the way over here is 0.28 for abbreviations. For now, I'll just put 0.28 because I'm running out of spaces. But that's what you're finding. You're finding these heights here and here. So all we're going to do is multiply 2 is my width. Now this height is my 0.6 repeated. We have a width of 2, height of 0.4, a width of 2, and a height of 0.28. So the area of the first rectangle, we'll label this 1, 2, and 3. The width is 2, and my height over here is 0.6 repeated. So let's go at least 4 decimals. And then we're going to do the second rectangle. So my width is 2. My height now is 0.4. And then the last rectangle, my width is 2, and my height is this 0.28, but we're going to go 4 decimals, so 0.2857. So multiply those, multiply those, multiply those, and then we're going to add them up, and that will be our estimate. So go ahead and do that, and then hit resume when you're ready for the answer. Okay, so when you multiply the first two together, you should get 1.3332. When you multiply the second together, you should get 0.8. And then when you multiply the last two together, you should get 0.5714. And then when you add them all up, you should get 2.7046. So rounding to 3 decimal places, 2.705. That should be my estimated area under this curve. Now, let's not forget to answer the last question. The last question says, state if your estimate is an over or under approximation. Well, we can clearly see that it's an under approximation because I have empty spaces here, and I know bad example or bad picture, but yes, empty spaces there. So we will say that this is an under approximation. All right, let's try example number 2. Okay, so similarly, they're giving us a function, f of x, and this time I want 2 subdivisions or subintervals of equal length, and they want you to estimate the right Riemann sum over the interval from 0 to 1 of this function f of x. Again, round to the nearest thousand, and then state if your estimate is an over or under approximation. So the interval that I'm speaking about is from 0 to 1, and here's my function. So let's first draw a picture. So why don't you guys go to the y equals of your calculators, get a picture, and then draw a sketch on your paper and hit resume when you're ready. Okay, so here should be your sketch of the curve. But notice the interval that I want is only from 0 to 1. So I'm going to make my 1 right here, just so that I can exaggerate it a little bit. And I want to know the width of the rectangles. Well, I only have this one space from 0 to 1, but I want 2 subintervals. So you're probably thinking we can cut it in half. And that's true, but let's just prove the formula. So the width of each rectangle is found by taking the b minus the a divided by n. Remember the integral from a to b, so therefore my b is 1 and my a is 0. So 1 minus 0 divided by n, where n is the number of subintervals or rectangles, which here they want 2. So 1 divided by 2 is simply 0.5 or 1/2. So here is your 0.5. And that will make our second rectangle. Notice how I have a space here and a space here. So remind me in class to show you how to get the 0.5 in your calculators, in your table, if you don't already know how to do that. But I'm just going to show you how to do the rest of this by hand. So if we're calculating the right Riemann sum, we're going to start at the right of the interval, go up to the curve, and we're going to draw our first rectangle. Then we're going to go to the second 0.5, go up to the curve from the right side, go over one space, or 0.5 rather, and come back down. And those will be our 2 rectangles. So we'll call this rectangle 1, and we'll call this rectangle 2. So we're going to, step 2, calculate the areas. All right, so the first rectangle, the width we know is 0.5, and now this height. Well, this height is found, it's the y value of whatever 0.5 is when we plug it in. So just to show you, we have a function f of x, and it's radical x. So if I want f of 0.5, all I'm going to have to do is plug in 0.5 underneath the radical. So this point right here, whatever this value, this height is going to be, it's technically the square root of 0.5. Up here, at 1, f of 1, we're just going to take the square root of 1, which we know is 1. So all the way over here, this height would be 1. So if I want to find the area of, say, rectangle 1, the width is 0.5, the height is radical 0.5. The width here is 0.5, the height is 1. So that's it. We're going to rectangle number 1, the length is 0.5 or width is 0.5. the height is radical 0.5. And then for rectangle 2, my width is 0.5 and my height is 1. So you can calculate the area of each of these separately and add them up like we did before, or you could actually just type these into the calculator with a plus sign in between them, and you're done. So it would be this plus this, and then we get our final answer. So why don't you pause the video, calculate your area, and then round it to the nearest thousandth, and hit resume when you're ready for the answer. All right, so you should be getting an area of 0.85355. So 3 places would make this 0.854. And that would be the area under the curve from 0 to 1. Now, is this an over approximation or an under approximation? Well, look at all this extra area up here. So clearly, this one would be an over approximation. Now, this area is a very small area because only from 0 to 1 is a very small curve. I just exaggerated the way that it looks. All right, that's it for right Riemann sums. If you have any questions, now's the time to jot it down. If not, we'll see you in class tomorrow. All right, have a good night.